Hello everyone, my name is Daniel J, and in this short video, we're going to explore hypothesis testing and its errors. What is hypothesis testing? Hypothesis testing is a statistical method used to determine if there is enough evidence in a sample data to draw conclusions about a population. Now let me simplify that for you. Imagine you're working in a company and your company might want to know if a new product design performs better than the old one. Hypothesis testing allows them to compare results systematically and draw reliable conclusions. Now let's talk about the history of hypothesis testing. The roots of hypothesis testing go back as far as the 1800s with the English ceremony, trial of the figs. This annual event ensured that newly minted coins contained the correct amount of gold or silver. Here is how it worked. Coins were randomly sampled and stored in a fixed box. Their weight was tested against a standard. If discrepancies were found, the master of the mint faced penalties. This method demonstrates the foundational steps of hypothesis testing, which is forming a hypothesis, collecting the data, analyzing the results, drawing the conclusions. In the early 20th century, statisticians like Ronald Fisher and Jesse Neyman formalized hypothesis testing into the framework we use today. It has since become an essential tool in science, business, and many other fields for making informed, data-driven decisions. Now let's dive into key elements of hypothesis testing. But don't worry, I'll make it easy to follow. Here's a quick question for you. Have you ever flipped a coin and thought, is this coin fair? That's essentially hypothesis testing in action. It all starts with two key ideas. Null hypothesis, H0. This is nothing unusual assumption. It says the coin is fair. Next one is alternative hypothesis. This is the what if scenario. It says the coin is biased. Now imagine you flip this coin 100 times and record the results. What's next? First, we set up H0 and H alpha, kind of like laying out the rules before starting a game. Then we collect the data, your coin flips, and calculate something called a test statistics. Next, we check the p-value. Think of this p-value as the evidence meter. A small p-value means strong evidence against H0. Finally, we make a decision. Do we reject H0 and say the coin is biased? Or do we fail to reject H0 and say there is not enough evidence to claim it's unfair? Now here is the kicker. Even if we follow the steps perfectly, mistakes can still happen. Let's explore those errors in the next slide. Understanding the errors. Okay, let's talk about those potential mistakes, which is type 1 and type 2 errors. Let me ask you, have you ever jumped to a conclusion only to find out later you were wrong? Yeah, that's kind of what these errors are. Type 1 error. Imagine you tell everyone the coin is biased when in reality it's completely fair. That's a type 1 error, like a false alarm. The chance of this happening is tied to the significance level, alpha. If alpha equal to 0.05, there is a 5% chance you will make this mistake. Type 2 error. Now imagine this opposite. You say the coin is fair, but it's secretly biased. That's a type 2 error, a missed deduction. The probability of this error is beta. Here is the fun part. These errors are like a seesaw. If you lower the chance of a type 1 error, you might increase the chance of type 2 error and vice versa. So choosing the right balance is crucial. Now let's quickly run through an example. A company claims the new light bulbs last 1000 hours, but a consumer group decides to test this. They randomly test 36 light bulbs and find the average lifetime is 980 hours with a standard deviation of 50 hours. Here is the process. Null hypothesis is the light bulbs last 1000 hours. Alternative hypothesis is the light bulbs do not last 1000 hours. We calculate the z-square using this formula and we get to know it is minus 2.5. At a significance level of 0.05, the critical value is plus or minus 1.96. Since our z-score is minus 2.4, which is outside the range of minus 1.96 to 1.96, we reject the null hypothesis. Now we conclude the data suggests the light bulbs don't last 1000 hours as claimed. See how hypothesis testing helps us make decisions based on data? It's simple yet powerful. Alright, let's wrap up by exploring how hypothesis testing is shaping the world. Did you know hypothesis testing is everywhere, often without us realizing it? Let me show you. A new drug claims to reduce headaches. Scientists run tests to see if it actually works. Hypothesis testing tells them if the improvement is real or just random. Have ever clicked on an ad? Like a businesses use A/B testing to decide which ad grabs your attention more. They test two designs. One might just be a hit. And then in manufacturing, your favorite snacks, companies use hypothesis testing to check if each batch has the same taste, size, and quality. That's why your cookies always taste just right. Now, here's the big takeaway. Hypothesis testing isn't just about numbers, it's about making decisions based on evidence. But with great power comes great responsibility. Balancing the risk of type 1 and type 2 error is the key to drawing reliable conclusion. Thank you.